Okay, we're going to start with learning how to solve a multi-step equation with algebra tiles. And so our first equation is 4x plus 3 equals negative 5. So 4x plus 3 equals negative 5. And you'll recall from our last lesson that a green rectangle equals 1x. So I have 4 of them. So I'm going to lay down my 4 x's. And I want to have plus 3. So I need 3 green tiles. So there's 4x plus 3. And what that equals is negative 5. So I need 5 orange tiles. Okay. And I need to solve this. So to get rid of I want one rectangle to equal one of, I want a one-to-one relationship over here, or a 1 to however many. So I need to get rid of these squares. I don't want any squares on the left. I only want squares on the right. So to cancel out my 3 squares on the left, as you call, one green and one orange cancel each other out. Since I added 3 squares on the left, I have to also add 3 squares on the right, because I cannot do one thing to one side that I did not do to the other. These cancel out, so they go away. Now that those have canceled out, I have 4 x's and 8 negatives. And if I arrange these together, I can see that every single x is equal to 2 negatives. And so the solution to this equation is that x equals negative 2. So that's how we'll use algebra tiles to solve a multi-step equation. Let's try another one. Recycling the paper. Let's see, I'll just make one up real quickly. There's not another example in the book. So 3x minus 5 equals 10. Okay, so 3x minus 5 equals 10. I have 3 x's. So there's my 3x. And I have minus 5. A little more room. So 3x minus 5 equals 10. Okay. Now I want to get rid of my 5 negatives, so I'm going to cancel them out with 5 positives. And since I added 5 positives to the left, I have to add 5 positives to the right. Oops, sorry. So that was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. There. There are my 5 positives added to the right. So I can take my negatives and positives that cancel each other out away. And now I need to make some sense of this to arrange it. I have 3 x's. So I want to break these tiles up into 3 groups. And I just keep manipulating them until I have them broken up into 3 equal groups. And I can see that in my 3 equal groups, I have 5 tiles. So if 3x minus 5 equals 10, 1x equals 5 because each x is equivalent to 5 tiles. Now I do want to do one thing to show what would happen if I had an equation that did not break up evenly. So let's do 2x plus 4 equals 1. Okay, because I know just off the top of my head that that's not going to work out to an even integer number. I'm going to show you what to do. 2x plus 4 equals 1. So I need to take 4 negatives to cancel out my 4 positives. And I'm going to add 4 negatives to this side because I added 4 negatives to the other side. And as you can see, one of my negatives is going to cancel out one of my positives, so I'll take that away. And then I'll take these away, the ones that have canceled out. And what I have left is I have 2 x's and 3 negatives. Now I can break that up, but I have 1 left over. Well, if I were to split this between these two, they would each get 1/2. So each x gets 1.5. So every x is equal to 1.5. And that's how we would do that. So if let's say, for example, I had 3 x's and they each got, sorry, that was a negative 1.5. So I had 3 x's and there was 1 left over. Well, they would be 1.33. So if this was the scenario, x would equal negative 1 1/3 because I would split this into 3 pieces. So that's just to show you what to do with algebra tiles when they don't break up evenly.
We are now on Chapter 2, Section 3 for solving multi-step equations, and we just looked at the algebra tiles for solving multi-step equations, but now we're going to solve multi-step equations algebraically. And we're going to start with defining what we mean by multi-step equation. Okay, a multi-step equation simply refers to an equation solved in 2 or more steps. In the last section, we solved single-step equations where we only had to complete 1 step, or in the case of the fractions, sometimes 2 steps to solve the equations, but really they're meant to be a single-step equation. Multi-step equations require us to solve in more than 1 step. So when we solve a multi-step equation, what we're going to be doing is we're going to be undoing what was already done. And we're going to work backwards from PEMDAS. So basically we're going to do SADMEP. So we're going to add or subtract first, then multiply or divide. Now some equations will require some things before that, but that's the basic principle, is we're going to be undoing what was done. So let's look at an example of a very basic multi-step equation. 11x minus 4 equals 29. Now remember, we're always trying to undo what was done. So what happened, our story of x. The story of x was this. Along came an x, and x was multiplied by 11. That's the 11x. And then 4 was subtracted. And then x and then it equaled 29. So we want to find out what did x equal originally. And so basically this is a puzzle to be solved. The first thing we want to do is we want to undo the addition or subtraction that occurred. So 11x minus 4, I'm going to add 4 to both sides. All the while I'm trying to get x alone. Okay, so negative 4 plus 4 is 4. So is 0. So I get 11x, and 29 plus 4 is 33. I divide both sides by 11 to cancel the multiplication, and x is 3. So this is a two-step equation. Let's try another example. Example B, a plus 7 divided by 8 equals 5. So we had an a, we had a 7, and we divided it by 8, and then it equaled 5. Now this does not quite 100% go backwards from PEMDAS because we have to get rid of the grouping symbol first. So we have to multiply both sides by 8 to cancel out this 8 division. And that gives me a plus 7 equals 40. Then I need to subtract 7 from both sides. And that gives me that a equals 33. Let's try another. 2a minus 6 equals 4. I want to get rid of the minus 6, so I'm going to add 6 to both sides. Again, always trying to get that variable completely alone. 4 plus 6 is 10, and then a is times 2, so I want to divide 2 to cancel that out, and a equals 5. Always moving away from the a, trying to get the a or the x or whatever the letter is completely alone. Let's look at another example. N plus 1 divided by 2 is equal to 15. I need to get rid of the division, so I'm going to multiply both sides by 2. Times 2 and divided by 2 cancel, leaving me with n plus 1. And n plus 1 equals 30, so I want to get rid of the plus 1, so I subtract. The 1's cancel, leaving me with n, and then 30 minus 1 is 29. Okay, as always in algebra, we're going to be dealing with some word problems. So let's write down our first example word. Okay, so here's our problem. Hiroshi is buying a pair of water skis that are on sale for 2/3 of the original price. After he uses a $25 gift certificate, the total cost before taxes is $115. So that's how much he has to pay. We want to find out what is the original price of the skis. So let's break this down into what we know. Okay, the sale is equal to 2/3 of the original. Okay, he had a $25 gift certificate, and then the total paid was $115, and we don't know the original price. So let's assign the original price the value of x. So our original price is going to be x. So what's happening? 2/3 of, remember of means multiply, so 2/3 of the original, that's 2/3 x. And then he had a $25 gift certificate, so we take the $25 away because that comes out of what he has to pay. And then it costs $115. So 2/3 of the original price minus the $25 gift certificate equals $115. Now to solve this, again, we're always trying to get rid of everything attached to the x, and we do the addition or subtraction first. So I'm going to add 25 to both sides because those will cancel out. leaving me with 2/3 x is equal to 140. And we can solve this in 1 step or 2 steps. In 1 step, I'm going to multiply by the reciprocal. And in 2 steps, I'm going to start by multiplying by the denominator. When I multiply by the reciprocal, those cancel each other out, and I'm left with x. 2 goes into 140 70 times, and 70 times 3 is 210. Or in 2 steps, my 3's cancel, leaving me with 2x is equal to 420. And then I divide both sides by 2, giving me that the original price of the skis was $210. Let's do 2 more word problems because we really want to work on breaking those down and pulling out the important information. Okay, so we're going to write this one down. Okay, so a music store has sold 3/5 of their hip hop CDs. Okay, so they sold 3/5 of CDs. But 10 were returned, so 10 came back. Now the store has 62. And we want to know how many did they have originally? So I'm just going to use C for CD. They sold 3/5 of the CDs. Remember that of means to multiply. So 3/5 C were sold, but then 10 came back. So when they come back, they get added back into the inventory, which made 62 CDs. So we need to solve this. So first I'm going to take 10 away to cancel out the plus and minus 10, leaving me with 3/5 C is equal to 52. And then I'm just going to do this one in 2 steps first. So I'm going to multiply both sides by 5. And that leaves me with 3C equal to, I want to say 260, but let me just double check myself on that. Yes, 260. And then I want to divide by 3. Hold on one moment. That's giving me a not even answer. I just want to make sure I wrote down the questions from the problems correctly. Hold on. Okay, I did write the problem down correctly. Looking back in the book, the answer that they gave me would have been for 2/5 of the CDs. So I think there was a typo in there somewhere. But when I divide, I'm going to get 86.6 repeating. And so I'm going to round and say 87 CDs originally. Whenever you have items that have to be whole numbers, for example, a CD, we can't have part of a CD. We're not talking iTunes, we're talking about physical CDs. And so whenever that happens, you need to round to the next highest whole number. Even if it's a number that would normally round down, we want to round to the next highest whole number. So there were 87 CDs. All right, let's do one more word problem. All right, so Lynn read 3/4 of a graphic novel over the weekend. On Monday, he read 22 more pages. And if he has read 220 pages in all, how many pages are in the book altogether? Okay, so he read 3/4 of the book. So 3/4 of book read originally, and then he read 22 more pages, and altogether that's 220 pages read. And we want to know how many pages in the book. So I'm going to use B for book. I could use P for pages. I could just use X because of whatever. But we're going to use B. Now 3/4 of the book plus 22 more pages is equal to 220 total pages read. We're going to solve this by taking away 22 pages because those cancel each other out. That leaves me with 3/4 B is equal to 220 minus 22 is 198. And then this one I'm going to go ahead and solve in one step. So I'm going to multiply both sides by the reciprocal. And then 3 goes into 198 66 times. So 3 into 198 is 66. And then 66 times 4 gives me that the book originally had 264 pages. Okay, that's the word problems. The next concept we need to work on is consecutive even, consecutive odd, and just consecutive integers. And so we want to talk about what that means. Okay, so consecutive is our next vocabulary word. Consecutive helps if I spell it correctly. And consecutive is in order with no interruptions. So when you talk about consecutive integers, these are numbers in counting order. So for example, 1, 2, 3, 4, 5, etc. counting order. And we can start anywhere. We can start at 23, 24, 25, etc. These are consecutive. Then we can have consecutive even integers. And those go up by 2. So 2, 4, 6, 8, 10, 12, etc. And we can have consecutive odd integers, which also go up by 2, but they start with an odd number, so they stay odd. 1, 3, 5, 7, 9, 11, etc. Now, consecutive integers, to get from a 1 to a 2, I added 1. To go from a 2 to a 3, I added 1, etc. And as I mentioned already, we add 2 on the evens, and we add 2 on the odds. Now, when we don't know what the integers are, well, the first one is x, but then what's the next one? In my numbers, I go 1, 2, 3, 4, 5, etc. To get from a 1 to a 2, I add 1. Okay, so if the first number is x, then the next number would be x plus 1. To get to the next number after that, I add 1 again, which means I've added a total of, to get from a 1 to a 3, I've added 2. To go from a 3 to a 4, I add 1 more, which means that to go from a 1 to a 4, I've added 3. Then to get to a 4, from a 4 to a 5, I add 1 more, which means that to get from a 1 to a 5, I've added 4. So as I go down my list of consecutive integers, the first one is x, then I add 1, then I add 1 more, and then I add 1 more, and then I add 1 more, etc. Okay, so these are a list of consecutive integers. If I have unknown consecutive even integers, okay, again, I will start with x, That's my first unknown. But let's look at a list of even integers. To get from a 2 to a 4, I added 2, and then I added 2 again, and then I added 2 again, and then I added 2 again. But to get from a 2 to a 6, I added 4. And to get from a 2 to an 8, I've added 6. And to get from a 2 to a 10, I've added 8. See, 2, 4, 6, 8. So with my unknown consecutive evens, I'm adding 2 each time. So I add 2, and then I add 2 more, and then I add 2 more, and then I add 2 more, etc. And the same thing happens with unknown consecutive odd integers. I start with an x, and let's make the list of odds. 1, 3, 5, 7, and 9. To get from 1 to a 3, I add 2. To get from a 3 to a 5, I add 2. To get from a 5 to a 7, I add 2. To get from a 7 to a 9, I add 2. To go from 1 to a 5, I've added 4. To go from 1 to a 7, I've added 6. And to go from 1 to a 9, I've added 8. So see, it follows the same patterns as the evens. So my first number is x, I add 2, and then I add 2 more, and then I add 2 more, and then I add 2 more, etc. Now what we will be told in the problem is to find 2 or 3 or 4 consecutive evens, consecutive odds, or just plain consecutive numbers. And this falls under a branch of mathematics called number theory. Number theory. And number theory is the study of numbers, specifically the relationships between numbers and how it all works. It's a very interesting branch of mathematics. All right, so let's do some consecutive problems, some examples. So example 1 is find 3 consecutive odd integers with a sum of -51. So let's back up here. Consecutive odd integers. I want to find 3 of them. 1, 2, 3. First, my second I add 2. My third I add 4. So I'm going to write these down. My first one, my second one, and my third one. And I want to have a sum, so that means I add them together. Let's do that in a different color just to sort of differentiate. So I add my 3 integers together and they equal -51. X plus x plus x, that's 3 like terms. That gives me 3 x's, and then 2 and 3 is 5. Okay, so my first step is to collect my like terms. Then I want to get that x alone, so I'm going to subtract 5 from both sides so that my +5 and -5 will cancel, leaving me with the 3x is equal to -56. I made a huge mistake. I am so sorry. I wrote +3 when I meant to write +4. See, x plus 2, x plus 4, and then I came down here and I wrote +3 like a silly person. Now I just added wrong. Okay, 6. 2 plus 4 is 6. So I'm going to subtract 6 from both sides, giving me not a 56, but a 57. Negative 57. Then I need to divide both sides by 3, and that gives me that x is equal to negative 19. Now I need to find all 3. So here's the first one. So my first one is negative 19. My second one is x plus 2, so that's negative 19 plus 2, so that's negative 17. And my third one is x plus 4, so that's negative 19 plus 4, which gives me negative 15. So my consecutive odd integers are negative 19, negative 17, and negative 15. So let's try another one. This time we'll just do regular consecutive. So we are going to find 3 consecutive integers with a sum of 21. Okay, so consecutive integers, my first one is x, and then I add 1, and then I add 1 more, because we're just talking about consecutive integers, not evens or odds. 3x's plus 3 equals 21. That was collecting like terms. Then I subtract 3 from both sides, and 21 minus 3 is 18. Then I divide both sides by 3 to get that x equals 6. But again, this is only the first out of the 3. I need to find all 3. So x plus 1 is 6 plus 1, which is 7. And x plus 2 is 6 plus 2, which is 8. So my list is 6, 7, and 8. Now, check these. How do you check these to make sure you got it right? Well, you're looking for a sum. So you add your 3 integers together and make sure that it matches. We can go back and do that to our last problem too. Negative 19, negative 17, and negative 15. And I get negative 51, which was what I was supposed to get, so I know that it works. And now we will go to the note-taking portion of Chapter 2, Section 3.
We want to do our note-taking review for Chapter 2, Section 3 of things that we should have learned, solving equations, using more than one operation. In Section 2, we just use addition, or we just use subtraction, or just multiplication, or just division, but here we used more than one. And solving equations involving consecutive integers. I like those problems. Okay, review vocabulary. Equivalent equations are equations with the same solution. So some words that mean that in some way. Okay, and then let's write the correct vocabulary next to our new vocabulary. Integers in counting order are consecutive integers. The study of numbers and the relationship between them is number theory. Number theory tells us how it all works. And an equation that requires more than one step to solve is a multi-step equation. Now, some books break things down into one-step, two-step, and multi-step. This book just does one-step and multi-step. So, multi-step is 2 or more steps. All right, we have a dictionary term to look up again, consecutive. So, I'm looking in the dictionary for consecutive. Consecutive. Okay, found connective and conscience. Consecutive. Following in order without interruption. Okay, so how will that help us remember the math definition for consecutive? Following in order without interruption means that we have numbers in order. Okay, you may have written something a little differently there, but either way it means the same thing. Okay, we have some empty steps here for solving multi-step equations that we need to fill out. We have 2x plus 3 equals 17. We want to subtract from each side. Now, they're doing it off to the side. I prefer to do underneath, but it's the same thing. 17 minus 3 is 14. Then I divide both sides by 2, and x equals 7. Okay. Write an equation for the following item and then solve. 3 consecutive even integers. Well, the first one is going to be x. The second one is going to be x plus 2, because that's the next even. And then the next one will be x plus 4. So my equation is going to be x plus 2 plus x plus 4. And the sum is 48. That gives me 3x plus 6 equals 48. I subtract 6 from both sides to give me that 3x is 42. I divide 3 from both sides, which gives me that x is equal to 14. Now, it would be great if they made these pens erasable because they'd be perfect for math. Okay. Explain why working backward is a useful strategy for solving equations. Working backwards is a logical thing to do, so it's logical. It allows us to check. It undoes the operations that have been done. So we don't have to just plug in a bunch of random x's trying to find the solution. We undo what was done to the x so that we can find the solution. You could have written a lot of things here. So if you have any questions on the assignment, let me know, and I am happy to help.